So apologies for the previous explanation. I tried to make things as simple as possible, but didn't turn out to be the case. Now I've tried my best here as well. And the reason why there will still be a confusion, actually the reasons why are two in in my opinion. One is the fact that I'm trying to teach you a new concept, which is coefficient of restitution, which is not supposed to be along the sides of laws of motion. Two, we're trying to incorporate that coefficient of restitution, which you're not used to, into a chapter that we're already doing questions so far. And that will be just in the first part of the chapter, which is Newton's laws of motion and action, right? So yes, I do understand that there will be a certain up to a certain extent of confusion and lack of clarity while we are solving this. It is very common. It is natural to have that. Okay, things will make more sense once you write down these notes along with me, teach this to yourself, and then the nomenclature of the parameters that are used here, which was confusing in the previous solution, will also be a bit more confusing here as well. But then all of those things would make better sense if you follow along. Okay, so please make sure that you write notes along with me, pause the solution, watch it one more time, or it's I do understand that it demands very much patience to watch it another time just for the sake of one question. But trust me, these little things matter a lot. It will help you significantly to master the concept. Okay. So we already discussed the definition of coefficient of restitution, which is the relative speed of separation divided by the relative speed of approach. So it actually, if we understand it like this diagram here, this moment here is the actual process of collision. Okay, so the two balls collide at this point here. And then they start to separate in the opposite direction. They were approaching in the same direction. Now, the direction here doesn't make much of a difference to understand the concept. What will happen if they come in the same direction? What will be the impact if they move in the same direction? If they move in the different directions? These are things that we will discuss when we come to the specific topic in work energy power. Let's not go through in detail here. Let's just have a surface level understanding of what's required here. So approach means coming towards each other with respect to the diagram here. In general, it means before collision. Separation means after collision. Okay. So the velocities of these two bodies, the difference between them is relative speed of separation. Separation here. Two bodies before collision, two velocities. The relative speed, difference between the two speeds, is the relative speed of approach, and the ratio of these two is coefficient of restitution. Okay. Now, in this case, the given question here, we have a ball which is being dropped from 10 meter. It comes to the floor and hits the floor. It goes back up. So the velocity by which the ball hits the floor is u1, which is velocity of ball before hitting the floor, just before hitting the floor. And u2 is the velocity, the initial velocity of the second object. The second object here is the floor. v1 is the final velocity of the ball after collision. So the ball leaves the floor. Just after leaving the floor, the velocity of the ball is v1, which is after collision. And what is v2? v2 is the velocity of the floor after the process of collision. Confusing? Yes, I understand. Let's revisit this one more time right away. And I want you to make a note of this and then say this along with me. What is E? V1 minus V2 by U1 minus U2. What is U1? U1 is the velocity of the ball just before collision. What is V1? V1 is the velocity of ball just after collision. What is U2? U2 is velocity of the floor just before collision. What is V2? V2 is velocity of the floor just after collision. Now, what is the meaning of these two lines here? Something that's been bugging you, isn't it? What would that be? This represents the magnitude of the velocity or the absolute value of this, which means even if the velocity is negative minus 3, we will take that as 3. Then we take only the magnitude of this. Even if it is plus 5, we consider only the magnitude, which is the 5 in here. Okay. Now let us apply this to the ball and the floor here. Object 1 is the ball. Object 2 here is the floor. Floor is at rest. So this is at rest because practically a floor doesn't move. U2 is equal to 0. What is U2? U2 is velocity of floor before collision. What is V2? V2 is velocity of floor after collision. So these two terms are 0, U2 and V2. So in this calculation here, we get V1 minus V2 as V1 minus 0. And U1 minus U2, U2 is 0, so that becomes U1 minus 0, which gives us from this equation, E is equal to magnitude of V1 upon magnitude of U1. Okay. Now the question comes, which has been bugging you right from the previous explanation regarding the direction of these velocities. But the direction changes, sign convention take down as negative. So moving downwards, negative, moving upwards, taken as positive here. So before impact, the ball is moving downwards. The ball is moving downwards because the ball is coming towards the floor here. And therefore, we take U1 as negative, which means U1 will be negative U. So the ball is coming down, it hits the floor, then it goes up. While it is coming down, U1 is negative. Why? Because consider the sign convention as moving downwards as negative and moving upwards as positive. Stay with me here, please. One more minute. Same concept. The ball is going up, sign convention, take up as positive, taking upwards as positive. So after rebound, when the ball moves up, the velocity is now going to be positive. So V1 here is positive, therefore V1 is plus V. Yes, exactly. This is what I was trying to tell you regarding the choice of nomenclature. The terms and the definition of it: U1, V1, V1, V2, UV, and then. So yes, that brings us a lot of confusion here. But trust me, let's calm ourselves. Let's be more patient. Let's try to understand what is written in the solution, and let us go through that a couple of times. And I'm really sure that things will make much sense to you. Okay. So the direction changes. It comes down and then it moves up. So what about the minus sign, which actually means the reflection of change in direction? Let's try to understand that, which we already have done one half of it. Let's try to understand that in terms of the floor as well. The floor is practically at rest. So U2 is equal to 0 and V2 is also equal to 0. Now, while computing relative speeds, what is relative approach speed, which means before collision? It is magnitude of U1 minus U2. What is U1? We just said that since U1 is the velocity of the ball before collision, it is acting downwards. U1 is negative U. So u1 is negative u2 is 0. Why is it 0? Because the floor is at rest before collision. So magnitude of negative u is u. Okay, are we done? Exactly, for the ball moving upwards, what is magnitude of relative speed after separation or after collision? Magnitude of v1 minus v2. What is v2? Equal to 0. Why? Because the floor is practically at rest. What is magnitude of v1? V1 is plus v. Why? Because it is plus because the object is because the ball is now moving upwards from the floor. So relative speed after collision is v. My bad. Relative speed after separation is v, and relative speed before separation is u, which gives us, right, which gives us e is equal to v by u. Might be still confusing. Please pause the solution here, watch it one more time, write down things along with me, and if things are clear now, let's move to the calculation part. Just to summarize here, v1 is negative u. What is v1? It's the velocity of the ball just before the impact. What is v2? V2 is plus v, which is velocity of ball just after the impact. I think this was one of the points which most of us here would be a bit confused with, right? Or maybe you would have thought better clarity would make sense. That is, the whole process here can be divided into three different instant points. One, during the impact, before it, and after it. Okay? Yes, there is something special with the process of collision in the exact moment of impact. Something we'll discuss in a while. Okay? Now, to go a bit further, in both these cases, when the ball is dropped from a height of 10 meter and when the ball reaches back to a height of 5 meter, equations of motion can be applied, which gives us v squared minus u squared is equal to 2as. Since this is dropped from rest, u square is 0. So v square is equal to 2as, which gives us 2 is a constant, a is a constant. Therefore, v is proportional to root of s1, which in this case is 10 meter. Likewise, when the object, the ball here hits the floor and it goes up after the impact, equations of motion still hold valid here, which gives us v square minus u square is 2as, a s2 here. In this case, final velocity is 0. Why is it equal to 0? Because it is momentarily at rest at 5 meters. Acceleration is minus g, minus by minus is positive. So again, u is proportional to root of s2. U is proportional here to root of s2. What is E is equal to? V by u. What is V proportional to? Root of s1. My bad. Okay. This is where the second part of confusion comes in regarding the choice of words here. Okay. So for the first part, v square minus u square is 2as. What is v? Is the final velocity. What is final velocity? Final velocity in this case is the velocity before impact. Okay, so v square minus u square is 2as. V is here v1 because it is velocity before impact. v1 square minus 0 is 2a into s. A is 9.8 plus 9.8. Why? Because acceleration due to gravity is acting downwards. Displacement is also downwards. So G is plus G direction, both of them in the same direction. Okay. Since it is dropped from rest, U is 0. So V1 square is 2 times 9.8 meters. V1 square is 196. Therefore, V1 is root of 196, which is 14 meter per second. So before impact, V1, the velocity of the object before impact is 14 meter per second. Okay. And we just said that E is V by U. What is V? Final velocity after impact. Final velocity after impact. What is U? Initial velocity, that is before impact. Okay. So E is actually V by U if you write it in final term, initial final velocity by initial velocity, but this is final after impact by initial by before impact. So I would like to write it as, just to make sure that you understand the concept clear here, I will write this as, say, after impact, the velocity is V2, right? So this is V2, and before impact, it is V1 here. Okay. So what can we write V2 from here? V2 can therefore be V1 times E. But we just found out that these two are actually equal to the are proportional to the height of it. So this is actually root of h2 divided by root of h1 here, right? Which gives us root of h2, which is root of h2, which is root of 5 by root of h1, root of 10, root of 5 by 10, which is root of 1 by 2, which gives us the value of E roughly as 0.707. Okay. Now, once you have the value of E, we can find out impulse, which is mass into change in velocity, mass into V2 minus V1. V1 is downwards, V2 is acting upwards, so they'll have opposite signs. V2 minus V1. V2 is V, V1 is minus U, minus is plus. So this gives us V plus U. What is V? E times U. Taking U common, U times 1 plus E. What is E? 0.707. 1 plus 0.707 is 1.707 times 14 times 1, which gives us I is equal to 2.89. Okay. So yes, I think we are still ending up with one, with at least certain amount of confusion regarding choosing V1, V2, U, and V. See, the reason why there is a confusion is because this follows the definition of E, and this here follows the calculation of, sorry, the other way around. The first part here gives us the definition of E, and the second part here is actually with respect to the given problem. I hope that makes sense. Okay. And even after going through these two definitions, if you feel that I have not made complete justice to the concept here, please feel free to write to me. I'll make sure that I attend to it and give you better clarity on that. Okay. Please feel free to reach out. All right. Let's now discuss a little bit more on this part of the subject here, which is the process that happens during impact. Okay.